Hi everyone, welcome back to our series. Hope you are doing good. This is Mahesh. In this video, we will look into Leetcode problem number 167. So basically this is a two-sum problem, which is a very famous problem which is being asked in many companies. So it is a continuation of Leetcode problem number 1, which is a two-sum problem. So that's a prerequisite to continue in this video. So if you have not watched that video, please go back. I'll be leaving that link in the description. So go back to that video, first look into that. So we will learn brute better and best solution if the array is not sorted in that, and this can be asked as a continuation or a follow-up question for that particular problem, or it can be asked as a separate question also. So with that, so if you have seen that video, maybe we will continue from there here. Okay, so let us try to understand the problem. So this is basically one indexed array of integers, and that's a numbers array, and that is already sorted in non-decreasing order, which means it's a increasing order array. And find two numbers such that they add up to a specific target number. Let these two numbers be numbers of index 1 and numbers of index 2, where index 1 and index 2, they lie between 1 and the length of the array numbers. Okay, so return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array, index 1 comma index 2 of length 2. So basically we need to return an array of length 2 which will contain index 1 and index 2. The tests are generated such that there is exactly one solution. So you may not use the same element twice. Your solution must use only constant extra space. Okay, so with that, maybe we can look into any constraints. So the length of the numbers array lies between 2 and 3 into 10 raised to 4, and the number in the array lies between -1000 to +1000, and numbers array is sorted in non-decreasing order. So this is a very important constraint that we need to keep in mind, and target can be anywhere between -1000 to 1000. The tests are generated such that there exactly one solution exists in the problem. Okay, so with that, let us switch to our editor and let us try to understand the problem. So here they have given this particular array of numbers, and they are indexed from 1, not 0. So 1, 2, 3, 4 and 5, something like that, and they will give a particular target. So now we need to return the pair of numbers which add up to give this particular target. So if you see here, 2 plus 7 will add up to give us 9. So we need to return the indexes of 2 and 7, and indexes of 2 and 7 is 1 and 2 here, because it's a 1 based indexing. So if you have already watched the previous video, so now what is the optimal solution that we have discussed in that solution? So normally what we do, we take a hash, basically hash map, and what we do, we will iterate over this particular array and we keep pushing the array and its index. Correct, right? So let us do that. Now what I will do, I will take 2, 7, 11, 15. Okay, and our target is 9. So now I will take a variable complement, and complement will be basically target minus any number. Okay, so I will start from here. So complement will be 9 minus 2, 7. Do we have 7 in the map? No, it is not, right? I mean, map is empty. So what I will do, I will simply push 2 along with its index, which is 1. Okay, now I will move to next number, which is 7. So my target will be 9 and my complement will be 9 minus 7, which is 2. Okay, Now I will search for this particular 2 in this map. If you see, our target exists in the map. If that is the case, then we will return this index and whatever the index that is there in the map, both we will return. So it is this index which is 1 and the current processing index. So we can simply return like this. So in this case, if you see, our time complexity will be order of n, but the space complexity will also be order of n here. So the interviewer will not be happy with this particular solution because we are using extra space. And also the constraint here is that our input array is sorted. So we can use this sorted property in order to come up with a pair in a most optimal way, that too without using extra space. Okay, let us see how to do that. Now let us again take the array 2, 7, 11 and 15 and our target is 9. Okay, now as explained in one of the previous videos where we have seen the introduction to 2 pointers, we will use 2 pointers technique to solve this particular problem. Why? Because here we know this particular array is already in its increasing sorted order. So if that is the case, we already have some structure already formed here. So with that, now what I will do, I will take 2 pointers. Okay, one is left pointer, or you can also call it as start pointer, and another one is right pointer. Okay, so left I will assign it with 1, right I'll assign with n. So n is basically our length of the array. So n equal to numbers dot length. So here it is 1, 2, 3, 4. These are the indexes. So instead of n, I will take 4. Okay. So now if you see, my pointer is pointing at these 2 values. Now I will add these 2 values. So 2 sum equal to 2 plus 15. If you see, we have 17. Now, is this 17 equal to our target? No. Right? So, if that is the case, now check whether this particular 9 is greater than 17 or less than 17. So, if it is less than 17, then we need to decrement the value, correct, right? So, it means we need to move towards left, because right side we have the max possible value and left side we have the smallest possible value. If you see the sum, it is 17, which is greater than 9. So in order to get the smaller number, we have to move this pointer towards left. We cannot move this pointer towards right. If you see 15 plus 7, I mean, if at all you move towards right side, 15 plus 27 will be 22. So which is still more greater than 17. So we need to try to reduce this sum. Okay. So for that reason only, what we need to do, we need to move towards left from the larger number. So if that is the case, now what I will do, in the next iteration, I will move the right pointer 1 level left. So if that is the case, now if you see, again my sum will be 2 plus 11, which is equal to 13. So if you see 13, again it is greater than 9. So it is still larger than whatever the target we are expecting. So now what I will do, I will again move my right pointer towards left. Okay, so if I move that left, now I am pointing my right pointer to 7. Now if I try to compute the sum, it is 2 plus 7, which is 9. Correct, right? So if this is the case, whenever I get my target, I will simply return the indices. So I didn't update this, but this will be now pointing to 2. So I can simply return my left and right pointer. Correct, right? So this is one example. We will little bit modify the target now. Now let us consider target equal to 26. If this is the case, now again we will start. This is one pointer, this is another pointer, this is our left and this is our right pointer. Now I will take sum, add these two values, 2 plus 15, it is 17. But if you see our target 26. So if it is 26, now it is the other case, right? Now my target is more than whatever the sum I have got. So if that is the case, then I need to increase the value. So there is no possibility to increase towards right because that's the maximum number what we have. So what I need to do, I need to increase the left pointer so that I'll move to the next next available greater number. Okay. So now if you see, I will move this pointer, then my left will be pointing to 7. So now what I will do, I will remove this. So it will be 7 plus 15. Now if you see my target, my sum is 22. But if you see target, it is 26. So it is still lesser than 26. Now again what I will do, I will increment the left pointer. So now it will be 11 plus 15. So it is 26. Now we got whatever target we want. So now what we can do, we can simply return this index and this index. Okay, let us try to write the pseudocode for that. Now what I will do, I will take a variable n, I will assign it with numbers dot length. Okay, but our arrays are in real time 0-based indexed. So let us take the left pointer to 0 and right pointer to n minus 1. We will tweak whenever we return the answer a little bit. So now we will use our while loop because we are trying to use the two-pointer technique here. So I will check until unless my left is less than right. What I need to do? I need to do something. So now what I will do, I will take a variable sum and I will say numbers of left plus numbers of right. Okay, so this will give us the sum. Now what I will do, I will check if my sum is equivalent to target, then we got our pair. Then simply return array. So that will be left plus 1 because it's a 1-based indexing, and also comma right plus 1. Okay, so this gives us the pairs. If that is not the case, if sum is not equal to target, then we will have to check if, else if, maybe we can use else if sum is less than the target. If sum is less than the target, then what we will do, we will increment the left pointer by 1. If that is not the case, then sum will be more than the target. So I will use else, simply decrement the right pointer. So at the end, if we don't get anything at the end of the while loop, we will simply return empty array. Ideally, this won't be the case because if you have seen the constraint properly, there will be for sure one pair that gives the target. So this block will for sure return us the pair. Okay, so this is the pseudocode, and if you see, we are finding the pairs in one iteration. That is, our time complexity is of order n, and if you see the space complexity, we are not using the hash map now. So it is a pretty much straightforward. So that's why our space complexity is of order 1. Okay. So with that, let us try to execute this and see. Let us take a variable int n and assign it with numbers dot len. After that, let us take a variable left and assign it with 0. Then int right will be n minus 1. Next, while left is less than right, what we will do, we will try to find the sum. Sum will be numbers of left plus numbers of right. Now let us check if sum is equivalent to target. If that is the case, we will return new int left plus 1 because the given input is in 1 based indexing and we are processing it in the 0 based indexing. Right plus 1. If that is not the case, we will check if our sum is less than target, then we need to increment left pointer. If that is not the case, then we will have to decrement the right pointer. Okay, if that is not the case, if we at all not found any pair, then we will simply return new int and empty values. With this, let us try to run and see. There is some issue. So it is accepted. Now I will submit. If you see, our solution got accepted successfully. So this is the most optimal way of solving twosum problem if at all the given input array is in sorted order. So hope you liked this explanation. If that is the case, please consider subscribing to my channel and also like the video, share it with your friends. And also if you have any queries or any problem that you want me to solve, you can add that as a comment in the video. Thanks for watching the video.